Let us talk about time and the space complexity. This is a very important topic and sometimes it is difficult for the students to understand. Though it is not that difficult, it's not complex. Though the word complexity is used, it's very simple. Let me explain you what does it mean by time complexity. Then afterwards I'll tell you about space complexity also. So first let us start with time complexity. See, in daily life, when we do any work, any task, we want to know how much time it takes for performing that particular task. Like suppose it is a 1 hour task or 1 day task. So that amount of time required depending on the work that we have to do. So usually in daily life, we measure the time based on the work that we have to do. So now we are using machines to do our work. That is computers to do our work. So we want to know how much time a machine takes for doing the same task. Like if a person is making a bread in 15 minutes, 20 minutes, then if you're using machine for making that bread, how much time that machine takes? We are interested in that one. If machine is taking 4-5 hours, then it's better to do it manually. So how much time a machine takes is very important for us. So we use computers for problem solving. What type of problem solving? The work that we do it using pen and paper. That same work we want our computers to do that. So computers are used for performing computation tasks. So computation also needs time. So we want to measure how much time a machine will take. So actually that depends on the process or the procedure for completing that task. So the time complexity basically depends on the procedure that you are adopting. So for giving you the idea, I have taken various examples. Using these examples, I'll explain you what procedure may take what amount of time. So let us start with array. See, this is an array of some size and some elements are there. So how many elements are there? See, this is the example already I have taken and you can count there are total 10 elements. But will it be always 10 elements? Or depends on the problem. So it depends on the problem. So how many elements may be there? The list of elements in an array, we say n elements. We don't know how many elements will be there. Maybe 10 or 10,000 or 10 million. We don't know. So we say n. N means some number of elements. That number of elements may start from 1 up to infinity. So we don't define infinity. So up to maximum number. Whatever the number you can imagine, you take that one. So n means not just 5 or 10. This is the first important thing. Mostly students get confused here. So n means some number of elements. So let us say there are n elements in this list. Now, what you want to do with these elements? I want to add all of them. So you have to go through all of them. Yes, one by one you have to take the element and go on adding it. So how much time it takes depends on the number of elements. So what is the time taken? N. We say n. The next thing, what do you want to do? I want to search for a particular number, whether element 12 is there or not. Search for it. Yes, it is there. I want to search for an element 21. Is it there or not? Check for all. No, 21 is not there. So at most, how much time it is taking? It depends on the number of elements that you have to compare. So how many elements are there? N elements are there. So what is the time taken? N. So the time is n. So it means in a list, if you have some n elements and you are going through all of them just once, then the time is n. So this n we represent it as a degree. So we can say order of n. We usually use the term order. Degree or order are same thing. So we use the term order of n. There are other terms like big O, omega, theta. That I will explain you at the end of the course, because till then you will be having the good understanding of time complexities. Then I can explain you what is big O, omega and theta. So throughout the course I'll be using term order of. So when we know what are asymptotic notations like big O, omega, theta, then you will understand how to use them. So let us say order of n. Then next very important thing. If you want to access that all the elements, then what the code that you have to write? For I assigned 0, I is less than n, I plus plus, then whatever you want to do here, means you want to add all of them or search something or count number of elements or finding maximum element, whatever you want to do, that logic come here. So that procedure comes here. So whatever the procedure may be. Then This for loop will taking us through all those elements 1. So how many elements? N elements. So what is the time out of n? Now listen, the very important thing. For finding the time complexity, either you can measure the time based on the work that you are doing, means what is your procedure. If you are clear with your procedure, you can know the time, or else from the code, program code also you can find the time complexity. If there is a for loop going through 0 to last element, means it's n, it's taking order of n time. Whatever is there inside will repeat for n times. So we analyze based on the procedure also, based on the code also. And the most confusing thing is when the code is given, we get confused how to analyze this one. So actually what the code is doing, you do that work and based on the work you analyze it. It's very simple. It's very simple. If you don't want to understand what the code is doing, then it's a difficult task. So if for loop is used, means there is a chance that time is order of n. Now let us move to the next situation. See, in this list, suppose being on the first element, I am comparing or processing all other elements once. Then being on the second element, again I am processing all other elements. Maybe I am comparing for sorting purpose, whatever the purpose may be. This 5 I am comparing or processing with rest of all the elements. Like that, for each element I'll be checking with all the rest of the elements. So for one value it will check for all, means n elements. Then for the next value also, if it is checking for all, processing for all, then n elements. So n elements are being processed. But how many times? For each element, n elements are processed. So this will be n square. This is n into n, that is n square. So we can say order of n square. So this is another case. Now in this same case, I'll show you one more thing. For processing like this, how the code should look like. The code should have nested for loop. Again I should have for loop, that is for j assigned 0, j is less than n, and j plus plus. And inside this I'll be writing that processing. Whatever the work I want to do, these will be the statements. So when you have two nested for loops, it's n square. Simple. You don't have to check line by line every statement and all. Just from the code you got the rough idea. You can say it's n square. But sometime for analyzing the code we check every line. So the idea is we should not miss any line. We should read it, check it thoroughly. That's why we write the time complexity. But overall the time complexity is written in terms of a degree of a polynomial. So it is order of n square. Nested for loop means n square. So let us follow it like a formula. Third situation for the same array. See, suppose being on first element, I am processing rest of the elements. So n minus 1 elements I am processing. Then being on the second element, I am processing rest of the element. I am not processing upon this one, right? So n minus 2. Then being on the third element, I am processing rest of them. It depends what you are doing, right? So imagine something you are doing. So you are processing rest of the elements. So this is n minus 3. Like that, it will be go on reducing. Then finally it will be 4 element, 3 element, 2 element, then 1. This is what? N into n minus 1 by 2. Sum of first n natural numbers. So this is not n minus 1. So this will be n square minus n by 2. So what is the degree of this polynomial? This is n square. So it's order of n square. So that's what the time complexity that we are writing the degree of a polynomial. See, this time I have done detailed analysis and I got a polynomial, and for that I got a function. That's like a function, and the degree of a function is n square. So time is n square. If same thing I write it in the form of a for loop, then this j will not be starting from 0, but j will be starting from I plus 1. See, now again two nested for loop. So at most this will take n square time. Yes. The next I'll show you one more situation. Fourth one. Let us look at this. I'll remove this one. Now in this array, suppose first of all we are processing the middle element. Suppose 4 is the middle element, right? There are total 10 elements. So fifth element, let us say middle element. Then next, either on the left side or on the right side, again we go on the middle. Suppose this is the middle element on this side. Then again middle element on this side. So in this way we are not processing the entire list, we are processing half of the list, then again it's half, then again it's half. So that process is always dividing the list by 2. So when something is successively divided until it reaches 1, that is represented as log, and we are dividing it by 2, half. So log of n elements, log n. So the time complexity is log n if we are not processing all the elements. Then if I write a code for that one, then the code may look like this. For I starts from n and I is greater than 1. I is getting divided by 2 every time. That's it. Now, just by looking at for loop, don't tell blindly order of n, because just now previously we saw order of n. Read it, how the for loop is behaving. That's why we check it thoroughly. When we are reading the code, we thoroughly check line by line, so that we should not go wrong. But overall, we need answer log n. If the value of counter I is getting divided by 2 every time, then it is log n divided by 2, log n base 2. And how long it is happening? Until it reaches 1. The same thing can even be written using while loop. See, I assign n, and while I is greater than 1, and some processing, I is always divided by 2. Same thing. Instead of for loop, you can use while loop also. Usually, when this is not incrementing 1 by 1 every time, for loop is not incrementing by 1 every time, we prefer using while loop. But in C, C++, Java programming, when for loops are there, people use for loop for this purpose also. For loop is used for counters which are incrementing by 1. So anyway, when this is written, you have to read it thoroughly and find out how much time it is taking. So we have seen 4 different behaviors of procedures that are performed on array, and also I have shown you the code and also shown you how we can analyze from the code, how we can analyze from the work. So if you are analyzing from the work, the process, that's more better. Now let us proceed ahead. See, this is a linked list. We'll be studying about this linked list data structure later on. This will be same as array. Like this is list and this is also a list. So what all we studied there, same thing applies here. The next is a matrix. Matrix is having how many elements? The dimensions are 4 by 4. So total how many elements? If dimension is n cross n, then total n square elements. So when you are processing upon a matrix, then it will require n square amount of time if you are processing all the elements. If you say no, I am just processing a row, then row is having n elements, order of n. No, I am processing just a column, so again it's n, order of n. If you are processing all elements, then it is n square. Now I'll show the code for that. I'll remove this. For processing a matrix of elements, we need 2 nested for loops. I++, and inside this for j assign 0, j is less than n, and j++. Now whatever you want to do with those elements, you can do that. So this is n square. Now for one element, if you're processing more upon that element, and that requires suppose a loop, or suppose you're calling a function which is having a loop, then the time will be more. For 3 for loops inside, then it will be n cube, right? If you are processing only 1 unit of time, just 1 statement or 2 statements are there, simple statement, no loops, then it's n square only. Then coming to this structure. This looks like array of a linked list, like linked list, right? So total how many elements are there? So here let us say n elements are there, these elements. So you can see that these are of different sizes. And here array of size m. So total how much processing you require? We have to process all these n elements as well as using this array. So we can say m plus n processing is required. If you say no, I don't want to consider this, I want to consider only the number of elements, okay, consider only n number of elements, order of n. What does it mean by considering, not considering? I'll give you the idea. Just listen as an example. Suppose you are giving a party to your friend. Some 4 or 5 friends, you have called them on a hotel for a party. Then what is the cost? The cost of the food that you are taking there. Then the bill at hotel plus traveling amount And if any extra other things that you are spending on, tips you are giving, do you consider that amount also and include it as the cost for a party? It depends on you. It depends on you. The same way, whether you want to analyze or not, it depends on you. So you should be in a situation to understand whether you need it or not. Right? Mostly what students believe that they are doing it because it is given as a task, as a challenge. So somebody's else job they are doing. So they get worried whether I should consider or not, why I should leave it. So that is your choice. You be in that situation and solve it. So that's all. If you say I don't want to consider this, means you are processing it, but you don't want to consider the time taken for that one. So only out of n. That's it. So this structure is over. Now last one, this one. This is a binary tree. So if you have a binary tree structure, total elements are 1, 2, 3, 4, 5, 6, 7. 7 elements are there. Then how much processing is done? Suppose you are processing, searching or something, and you are processing upon the elements only along the path, like this one, then this one, or this one, or this one, then this one, and this one. Suppose you are processing just along a path, then what is the height? It depends on the height. So how many elements you are processing? See, there are some elements divided by 2, then divided by 2 until it reaches 1 element. So total 7 elements are there. As from the bottom, if you see, the number of elements are divided by 2, then divided by 2. So it looks like log n. Yes, log n base 2. So we'll be studying about this one. So if you are spending time upon a tree along the height of a tree, then it is log n. Next situation, if you say no, I want to process all the elements, then how many elements are there? N elements. So it is order of n. Then whatever the program code that you write for processing this one, that code also will be order of n only, if you analyze that one. So this is the general idea I have given you about the time complexity. So the time complexity is soul and soul dependent on the work that you are doing. Now a little bit on space complexity. We want to know how much space is consumed in main memory during the execution of a program. So array, n elements are there. So it's order of n. This is n elements are there. Order of n. Space is n. Means n integers or n floats or n doubles, whatever it is. N elements we say. We are not concerned about the number of bytes, right? We are not concerned about that. We are not calculating that. We want to know the space is dependent on what? N. If the value of n is more, the space will be more. That's what the idea is. Then here also it's n. But along with the element, you need space for links also. So let us say 2n. 2n again, the degree is what? Order of n. Then coming to this space is n square, and this place is m plus n, and the space here is n nodes are there, so it's n, order of n. So the next video I'll take few program code and show you, so without looking at the processing, just from the program code how to find out the time complexity I will show you. So that's all in this video.